So the purpose of today's workshop is to briefly give you guys an idea of the application of data science, especially the programming language and RStudio, the interface to political science and other social sciences. Before I go into specific details about what kind of codes political scientists and social scientists normally and frequently use in RStudio with the help of this Tidyverse package, I will be briefly talk about some preliminary and basic information we need to know before we start our research design and before we analyze our data. As you can see on the slide, I got this graph from a data chem course I took before. So there are some basic steps we have to be aware of when we want to run analyses using R and RStudio with our data sets. So the basic steps normally start with importing our data into the R environment, and then we want to tidy it up, clean it up, so that we can run further analyses. After that, we transform our data sets into the forms that we want, and we will visualize them if we want to produce some kind of graphs or tables. By visualizing our data sets and visualizing our research results, we enable the audience or the readers to easily see what is the point of our research and what kind of results we're getting from our data sets. So this is called the communication with the other people. So before we run analyses using R and RStudio, there are several points that we have to clarify. We have to be aware of about our data sets. So one of the most important things we have to keep in mind is the types of the variables we are dealing with. So if we are dealing with numerical or quantitative values, we can have two types. One is continuous variables, which means that it can take the form of infinite number of values within a specific range. And another type is the discrete type of variables, which means that it can only take specific steps. It doesn't have an infinite number of variables within the range. On the other hand, if you are dealing with categorical or qualitative variables, we're dealing with information of distinct categories. So the first type is probably ordinal. So we have a finite number of values within a given range, and normally they are ordered according to a specific criteria. And also there is not ordinal information, which means that it is probably not numeric and it's probably hard to be represented by numbers. Other than the types of variables we're dealing with, we also have to be very clear about the relationships between variables we are dealing with. So basically, there are several different ways to categorize relationships between variables. So there is linear relationship, quadratic relationship, nonlinear relationship, and also there is unimodal, bimodal, single peaked, and so on. So there are some different categories you can allocate to the relationship you are investigating. And also you have to be careful about the direction of the relationship, whether it's positive or negative. And also, if you are dealing with correlations and regressions, then the strength is also important. And also, if you are using data sets that contain a lot of data points, probably there are some kind of outliers which fell out of the normal range of your data. Then how you can deal with those outliers is something that you have to think about. If you want to run some basic summary statistics using your variables, you have to be very clear about the type of the variables you are dealing with. If you are getting something like averages, maximum and minimum values, or standard deviations and so on, you have to understand what they actually represent. If you're getting some kind of graphs from your data visualizations, you should be aware that there are several different ways you can probably categorize or model your relationships. So different ways of categorization, it might lead to different research conclusions and so on. So after talking about the types of variables and types of relationships, I'll be discussing briefly about research design and methodology. So in the field of political science and some other social sciences, there are basically two primary types of studies in empirical analysis. One is observational, one experimental. So for observational studies, we are dealing with second-hand information and second-hand data, which is already available online or in some other research. For experimental studies, we are designing an experiment, and then we try to collect information and data from this experiment design we're having. In other words, for observational studies, we're dealing with secondary data. But for experimental studies, we're dealing with first-hand data that we have collected. A simplified version of experimental studies is a survey. So in that case, if we want to largely represent our population of interest, we have to be careful about the sampling strategies we're doing, whether it's simple random sample or stratified sample, and whether it's a multi-stage sample. If we are dealing with very complicated demographic distribution of some populations we're interested in, we have to be clearly aware of the possible flaws and limitations of our sampling procedures. And importantly, we have to be aware that observational and experimental studies, they both have advantages and disadvantages, pros and cons. So for observational data, it is likely that they have large external validity because other researchers and huge projects, they've already collected those data and probably they have been very careful about collecting them. And if their data sets are very large, then when you run analysis, it's likely that you can reduce your biases. And also it's probably more cost effective because you don't have to really do the field experiments and do those surveys because you have those available data online. However, a problem with observational data is that when you want to sort of infer causation and causality from your data sets, it is probably hard because in the real world, there are many different confounding factors and there are so many complexities so that you are unable to control the other factors influencing your variables of interest so that the causation is hard to imply. On the other hand, if you're having a experimental study, then if you're doing randomized controlled trials or double-blind experiments like the medical or biological studies, then you can manually, you can, with your research design, control the confounding variables. In that way, you can imply causation from your research results. So when it comes to the scope of inference, there is always a trade-off. For observational studies, the generalizability is large because we are having large data sets from large populations. But the causation is low because we cannot control many confounding factors. On the other hand, for experimental studies, we do have good causation because we can manually control some confounding factors. But the generalizability is low because we only have a small number of subjects controlled in our lab environment. We don't know whether they still imply the same thing in the wider world. So for many political scientists, they eventually want to shed some light on causal relationships, especially the direction of the causal relationships. But we have to be aware that it is very hard to imply causation, whether it's observational or experimental studies. And it is probably easier to conclude with correlation. It is possible that X causes Y and Y causes Z, but it appears that X causes Z. So sometimes we can statistically find that X and Z are correlated, but it is probably not a good idea for us to conclude that X causes Z. So we have to be very careful when we use the word causes. But nevertheless, it is probably useful for us to model our regression equation and other types of relationships in terms of independent or explanatory variables and dependent or response variables. And also we have to be aware that when we include some control variables and some other factors into our equations, we are probably dealing with multivariate or multivariable relationships. In that way, probably we have to adjust our regression models to capture those complexities. So in the rest of the workshop, I will be going through 6 sections that tries to familiarize you with data in R. So the first section is the language of data. I'll be talking about how to load data into R, how to make a table to explore your data sets, how to job levels, and create new variables. For the second section, I will be talking about data wrangling, how to load packages, how to filter your data sets, how to sort your data sets using the arrange verb, and how to do that in descending order, and how to change your variable using the mutate verb. And lastly, how to combine different verbs and commands at the same time. For the third section, I'll be talking about data visualization, how to use the ggplot2 package, how to assign your variables into your ggplot, and how to use the log scales for your axes in the ggplot, and how to change the color aesthetic, the size aesthetic of your data points, and how to use faceting. So for the fourth section, I will be talking about grouping and summarizing, how to use the summarize verb, how to summarize into multiple columns, how to summarize by your request, and how to visualize population over time and start your y-axis at 0. So for the fifth section, I will be going into details from the third section into visualizations. So there is scatter plot and line plots, and there is bar plot, histogram, box plots, and violin plots. I'll be talking about the verbs to create each and every of those plots in RStudio. So in the last section, I'll be talking about correlation and regression in R. I'll be talking about creating scatter plots using the simple regression model and using box plots as discretized or conditioned scatter plots. And also I will be talking about how we can identify the outliers and how we can see the correlation coefficients and other numbers that are associated with our simple regression model. And lastly, I will be talking about how to deal with missing observations and how to allocate the best fit line. So this workshop only provides a very basic and introductory level of information regarding summary statistics and regressions in R with the help of Tidyverse and ggplot. If you are interested in more advanced level or intermediate level of techniques in R, such as sampling and other multivariate regressions, then you should really go to read some econometric textbooks.